You know that old saying, data is the new oil?
Mm,
It's a great slogan, but it totally misses the messy reality for most companies. If data is oil, then most places are storing it in, like leaky buckets scattered all over the place.
that is a painfully accurate description. It's rarely a pristine reservoir.
Right. It's that classic headache.
Yeah.
The old file server. You've got contracts in London, blueprints in New York, HR files on a drive under someone's desk.
And the whole thing is aging, backups are a nightmare, and your VPN users are complaining it takes forever just to open a spreadsheet.
And the simple answer is always, oh, just move it to the cloud. But it's not that easy.
No, you can't just rewrite 20 years of applications to use, modern cloud APIs. And you can't retrain an entire department to stop using the S drive they've known forever.
Exactly. You don't want to reinvent the wheel, you just want it to stop falling off.
Oh.
And that's our mission for this deep dive. We're unpacking a whole stack of resources on Azure Files.
Yeah, we're going to look at how you can take that chaos and modernize it, but without totally disrupting how people work.
It's about bridging that gap, right?
It is. It's about getting the scale and resilience of the cloud, but presenting it in a way that feels just like that old server everyone is used to.
And one thing that jumped out at me was this idea of serverless file sharing, which honestly always makes me a little skeptical.
That's fair.
Serverless usually just means someone else's server that I can't debug.
Huh. Yeah, I get that. But in this context, it's actually literal. I mean, you're not spinning up a VM, you're not installing Windows Server, you're not patching it.
So it's a true platform as a service.
It is. You just get the file share, and Microsoft manages all the underlying hardware and the OS.
Okay, so let's set a baseline. When we say Azure Files, how is that different from, say, Azure Blob Storage? Because they both just store data in the cloud.
They do, but they're for completely different things. Think of it like this. Blob storage is a massive bottomless bin. It's a flat namespace for unstructured data.
Like video files or backups.
Exactly. And you access it with REST APIs. You don't mount a blob container as a drive letter on your laptop.
Right, I'm not hitting save as in Microsoft Word to a blob URL.
Exactly. Azure Files, on the other hand, is a structured hierarchy. It has directories, folders, files. It speaks the languages that your operating systems already know.
SMB and NFS.
Server message block and network file system, that's right.
So for a lift and shift scenario, if I have an old app that's hard-coded to look for server share, Azure Files is the answer.
It's the perfect drop-in replacement. The app has no idea it's talking to the cloud. It just works. Windows, Linux, Mac OS, they can all connect.
And what about scale? Can this actually replace, the big on-prem storage arrays?
Oh yeah, it's enterprise grade.
Yeah.
A single file share can go up to 100 TB.
100 TB.
And a single file inside that share can be up to 4 TB.
Wow. 4 TB for one file. What even is that? A massive database dump?
Could be, or a VHDX file for a virtual machine. The point is, you don't have to buy all that hardware up front. You're just paying for what you use.
Okay, that makes sense. But let's talk performance. Because the cloud isn't a magic wand. If I put a high-speed database on the wrong kind of share, I'm going to have a bad time.
You absolutely will. And that's where the tiers come in. The documentation is really clear on this. You've basically got two main options, standard and premium.
Okay, break those down for me.
Standard is your workhorse. It runs on traditional hard disk drives, skinning platters. It's hosted in what they call a GPv2 storage account.
So this is for general file sharing, home directories, that kind of thing.
Exactly. Dev test environments, the latency is acceptable, double-digit milliseconds. But the key thing here is you often pay for transactions.
So every read, every write, every directory listing has a tiny cost.
It does, and that can really add up with a chatty application.
Right. So what's the alternative?
That's premium. Premium shares are backed by pure SSDs. They live in a specific account type called file storage.
And that gives you much lower latency.
Consistent, single-digit millisecond latency and really high IOPS. This is for your high-performance workloads.
Okay, so a database or something that's really I/O intensive.
Yes, and the pricing model flips. With premium, you pay more for the provision capacity, the size of the share, but the transaction costs are generally included.
Oh, that's a critical difference. So for a super busy share, premium might actually be cheaper in the long run.
It can be. It's not just fast versus slow, it's provision versus transactional billing. You have to do the math.
Okay, let's move to the scary part, security. We're taking all our corporate data and putting it on a public cloud endpoint. How do we lock the front door?
This is probably the most critical step. The sources lay out 3 ways to authenticate, and they are definitely not created equal.
I saw access keys listed first pretty much everywhere?
They are because they're the easiest,
Hmm.
but they're also by far the most dangerous. Every storage account has 2 of these keys.
And they're basically the master keys to the whole thing.
The keys to the castle. They give you full admin rights, read, write, delete, change permissions, everything.
So if I hard code one of those into a script and it gets checked into a public GitHub repo.
It's game over. You've exposed everything. The best practice is flashing red lights. Do not use access keys for day-to-day access.
Okay, so what's the middle ground?
That would be a shared access signature, or SAS. Think of it like a valet key.
Ah, okay.
You use the master key to generate a temporary token that says, this person can only read this one file, and only for the next hour, and only from this IP address.
So that's useful for like an application or a script that needs temporary access.
Exactly. But you can't ask your users to do that every time they open a Word doc.
No, you'd have a revolt on your hands. So for users, what's the gold standard?
It's identity-based authentication. This is where you integrate with your Active Directory.
Your on-prem AD or Microsoft Entra ID.
Correct. And when you set this up, it becomes completely seamless for the user.
So if I'm logged into my work laptop, I just double-click the map drive and it opens. No extra password.
No extra password. It just works. And, this is huge, it respects the same NTFS ACLs, the access control lists, that admins have been using for decades.
I want to pause on that because that's massive. You don't have to learn a whole new cloud permissions model.
You don't. You can literally copy your data and your permissions from an old Windows server right into Azure files, and they stay intact. It's critical for compliance.
There was one networking gotcha that I think we need to call out. Port 445.
Yes, the classic port 445 lock.
So SMB traffic uses that port, right?
It does.
Yeah.
And the problem is almost every home ISP and a lot of corporate firewalls block outbound traffic on that port by default.
It's a security thing, left over from things like the WannaCry ransomware.
Exactly. So if you're working from home or a coffee shop and you try to mount your Azure file share directly,
It just won't connect. It'll time out.
it will. The solution is usually VPN or a newer protocol like SMB over QUIC, but it's a hurdle you need to be aware of.
Good to know. Don't blame Azure when it's your ISP.
Precisely.
Okay. We've built the share. We've secured it.
Okay.
Now let's talk about disaster. I wake up in a cold sweat because someone just deleted an entire project folder.
Right, the oops moment.
What's my safety net?
You have 2 main layers of defense here. The first is snapshots.
Point-in-time copies.
Yes, but they're incremental. So when you take a snapshot of a 10 terabyte share, it's not duplicating 10 terabytes of data. It only tracks the changes.
So they're really storage efficient.
Very efficient. And this is what powers that previous versions feature in Windows that users love. They can right-click a file and restore the version from an hour ago all by themselves.
No help desk ticket required. I love it.
Yes.
But what about the real nightmare scenario? An attacker gets in, or a rogue admin, and they just delete the entire file share. The snapshots go with it, right?
They do. And that is exactly where soft delete comes in.
The ultimate recycle bin.
That's a perfect way to think of it. It's a recycle bin at the storage account level. You've set a retention period, say 14 days. If a share gets deleted, it's not actually wiped. It just enters a soft deleted state. It's invisible, but it's still there.
So I can literally undelete the entire share with all of its snapshots intact.
You can. It is your absolute last line of defense against ransomware that tries to delete your backups. You just bring it back.
Wow. That feels like a setting you just turn on and never, ever turn off.
It's cheap insurance. Absolutely.
Okay, let's talk about managing all this. The Azure portal is fine, but it can get a little clunky. The notes mention a specific tool, Azure Storage Explorer.
This is the power user's best friend. It's a standalone app for Windows, Mac, and Linux.
And it looks kind of like a regular file explorer.
It does, but it connects directly to your Azure storage accounts. It's just much faster for managing access policies, uploading huge batches of files, digging into metadata. It's an essential tool.
A mandatory install for any Azure admin, it sounds like.
I wouldn't run a production environment without it.
Okay, so we've saved what I think is the killer feature for last, the thing that solves the biggest problem with cloud storage, latency.
Ah, yes.
Yeah.
Because your users don't care about your cool cloud strategy if opening a big file takes 5 minutes.
Exactly, and that's where Azure File Sync comes in. Walk me through this.
The concept is actually pretty simple. You take a local Windows server, say in your branch office, you install a small agent on it.
Okay.
Then register that server with your Azure file share. The cloud becomes the single source of truth, the master copy. But the local server acts as a performance cache.
So when my user in London opens a PowerPoint, they're pulling it from the server down the hall not from a data center across the ocean.
That's it. They get local, land speed performance. But here's the magic trick. Cloud tiering.
This is how you avoid needing a giant server in every office.
Right. Your London office might only have a 4 terabyte server, but the share in Azure is 100 terabytes. You can't sync everything.
So how does it decide what to keep local?
It uses a policy you set. For example, always keep 20% of the local disk free. As the drive fills up, the agent looks for the coldest file stuff nobody has touched in months.
And it offloads them.
It strips out the file content from the local disk, but it leaves behind a pointer, a reparse point,
A ghost file.
a ghost file. It looks like it's there. Same name, same size. But the icon is grayed out. The moment a user double-clicks it, the agent seamlessly recalls the data from Azure in the background.
And the user barely notices.
There might be a tiny delay, a second or two, but to them, it just works.
That completely changes how you think about hardware. My branch office servers are just disposable caches now.
They are. And think about DIR. If that London server dies,
In the old world, I'm restoring from tapes for days.
now, you get a new server, install the agent, and point it at the share. It instantly downloads the namespace, all the ghost files. That takes minutes. Your users see all their files and can get back to work. The data downloads as they need it.
You're back online in under an hour. That's incredible.
It is.
But I have to ask the hard question. Sync conflicts. What happens if Alice in London and Bob in New York open the same spreadsheet at the same time and both hit save?
That's the key limitation to be aware of. Azure File Sync does not do distributed file locking across regions.
So it can't stop them both from writing to it?
It can't. If they both save, you'll get a conflict. The system is smart enough not to lose data. It'll save both copies, but it will rename one of them.
So someone has to go in and manually merge the changes.
Correct. So it's fantastic for general-purpose shares, but maybe not for, say, a high-intensity CAD environment with multiple people live editing the same file across the globe.
That's a fair trade-off. Okay, let's wrap this up. We started with the idea that legacy file servers are a huge drag.
And we looked at Azure Files as that bridge to the cloud. Managed SMB shares that just work with your existing apps.
We talked about tiers, learning that premium isn't just about speed, it's about the billing model, and that identity-based auth is the only way to go.
We covered protecting your data with snapshots for the little mistakes and soft delete for the big ones.
And finally, we saw how Azure File Sync and cloud tiering can turn your local servers into smart, disposable caches.
It really is a best-of-both-worlds hybrid solution. You get out of the hardware business and focus on the data.
Which brings me to the thought I want to leave everyone with. We talked about cloud tiering, right? This idea that a file on your server, it looks real, but it's just a ghost, a pointer to data